Okay, so we're going to take a look at a new quantity today called the variance, and the variance gives us an idea of the spread of our data. Okay, so the way we define the variance var of x. Okay, so that means the variance of a random variable x, and we define this to be the expectation of the random variable x minus the expectation of x squared. Okay, and this makes sense because if we take the random variable x and subtract it from the expected value of x, this just gives us an idea of how far we expect the average point to be away from the mean. Okay, so that's all well and good, this definition makes sense, but it's not particularly easy to calculate in this form, so we rearrange it into a form that you may be more familiar with, you might have seen before, but if not, it doesn't matter. I'm going to run through it now, and that form's easier to calculate. So we, sorry, I've put the square in the wrong place, it goes after this bracket. So we expand out the bracket, so we get this expectation is the expectation of x squared minus 2x expectation of x plus the expectation of x all squared, okay? And using the linearity of expectation, we can write this as e to the x squared minus, no, we'll go plus for now, yeah, minus the expectation, plus the expectation of minus 2x e to the x, not e to the x, the expectation of x, and then plus the expectation of the expectation of x all squared. And this is because the linearity of expectation means we can separate, if we've got a sum inside an expectation, we can separate out those into the sum of the expectations of each individual part of the sum. So the other part of the linearity of expectation tells us we can take out constants as well, which is nice. And e to the x is actually a constant, okay? The expectation of a random variable is a constant, and therefore so is the expectation of x squared, that's also a constant. So we can drop this expectation here because we're just taking that out, and then we have the expectation of 1, which is just 1. We can take out minus 2e to the x from here, so then we're left with minus 2e to the x times e to the x, so we'll see this here. So we get this expression. Oh, I keep saying e to the x, I mean expectation of x, plus expectation of x all squared. Of course, the expectation of x multiplied by expectation of x is the expectation of x squared. So this whole expression is equal to the expectation of x squared minus the expectation of x squared. And these are two quantities we can calculate just using the definition of expectation. So that's lovely. That's what we're going to do in this video. So this is a nice proof to remember because it's nice and simple, but it starts to get you used to the ideas we use in proofs in statistics, where we're essentially just using the properties of the objects we're working with and working through systematically. Okay, so thanks for watching this video. If you did enjoy, please be sure to leave it a like. If you've got any questions, let me know down in the comments, but for now that's it, and I hope to see you in the next one.